Ohm's law is one of the most basic principles in electronics, yet it is not an actual physical law. Understanding Ohm's law is critical to understanding how electric circuits work. Understanding why it is not an actual physical law is critical to understanding the basic principles of logic and the nature of physical laws. Suppose we have a battery and a device which we call a resistor. The battery will create a voltage, causing charged particles to flow around the loop. On the other hand, the resistor tries to prevent the charged particles from flowing. The number of charged particles that pass by each second is what we refer to as the current. There are 3 ways to increase the current. The first way to increase the current is to use more batteries to create a larger voltage. The second way to increase the current is to use a resistor with a smaller resistance. The third way to increase the current is to use several resistors in parallel. Having several resistors in parallel is the same as having one resistor with a much smaller resistance. On the other hand, having several resistors in series is the same thing as having one resistor with a much larger resistance. Let us create a precise mathematical definition for the word resistance. Suppose we take the voltage across the resistor and divide it by the current passing through it. The result of this division is what we will define as the resistance. This is what we refer to as Ohm's law. However, this is not really a physical law, but simply the arbitrary definition that we created for the word resistance. Physical laws tell us how the universe works. Ohm's law would tell us how the universe works if, for example, the value for the resistance of a material always stayed constant. However, this is not the case. As current passes through a material, the material heats up. As a material's temperature changes, its resistance also changes. With most resistors, this effect is relatively small. In the case of some resistors, this effect can be very large. If this effect is large, we can use it to our advantage by using the resistor as a temperature sensor. By placing a voltage with a known value across the resistor and measuring the current that passes through it, we can calculate the resistance of the resistor. This would give us information about the resistor's temperature, and therefore also give us information about the temperature of the material that the resistor is in contact with. Temperature is just one of the many factors that can cause the resistance of a material to change. However, when we say that the resistance changes, all this means is that if we take the voltage across a resistor and divide it by the current passing through the resistor, we will not necessarily always get the same number. The fact that the number that we get at any given time is always equal to the resistance of the material is simply due to the fact that this is how we defined the word resistance in the first place. There are many examples in logic where a statement is always true simply because of the way in which we created our definitions for the words. And the statement doesn't actually tell us anything about the external world around us. This is one of the logical fallacies we need to watch out for, both with regards to science and also with regards to life in general.